So we got the value of breakaway point as minus 0.845. So this is the breakaway point, and with respect to this point, one root locus branch will go to infinity asymptotically, and another root locus branch again goes to infinity asymptotic to this asymptote, that is put here. Now the next step is to find the angle of departure and angle of arrival. So here, with respect to this problem, there are no complex poles and zeros. So if there are no complex poles and zeros, no need to find the angle of departure and angle of arrival. So there is no angle of departure and angle of arrival because there are no complex poles and zeros. Now the next point is to find the crossing point of imaginary axis. That means this point and this point, okay, the crossing point of imaginary axis of root locus. So for that you have to write the characteristic equation of the system. So what is the characteristic equation of the system? The characteristic equation is, take the determinant of closed loop transfer function and equate it into 0. So by applying the formula g divided by 1 plus g, we can get the determinant as s cube plus 6s square plus 8s plus k equal to 0. Now substitute s is equal to j omega. So what will happen? J cube. What is j cube? J cube, we can write j cube as j into j square. We know that j square is equal to minus 1, so it will be j into minus 1, j into minus 1, that is minus j. So j cube is minus j. So substitute s is equal to j omega here. So when you substitute j omega all cube plus 6 into j omega square plus 8 j omega plus k equal to 0. So if we substitute that, we will get the value as minus j omega cube and j square equal to minus 1. So we can write this as minus 1 into 6, that is minus 6 omega square plus 8 j omega plus k equal to 0. So we can take real part and imaginary part separately. So take the imaginary part, write the imaginary part, that is minus j omega cube plus 8 j omega, then equate it into 0, because here in the right hand side it is 0. So when you equate that is equal to 0, imaginary part to 0, we will get minus j omega cube is equal to minus 8 j omega. J and j cancel out, minus sign also cancel out, then we will get omega square is equal to 8 and omega is equal to plus or minus root 8, that is plus or minus 2.8. Now take the real part. So what is real part here? Minus 6 omega square plus k equal to 0. So substitute for omega square is equal to 8. From this we know that omega square equal to 8. So substitute that value here. Now we can write minus 6 into 8 plus k equal to 0, or k equal to 48. So the value of k at the crossing point is 48. So the value of k at the crossing point is 48. Okay, the value of k open loop gain at crossing point is 48. And what is this? What is the crossing point? Which one is the crossing point? We know that at the crossing point we can see that This is the crossing point of j omega axis. At this crossing point, the real part will be 0 at this crossing point. Okay, the real part will be 0 at this crossing point, and we got the real part is 0 at this crossing point, and we already have from this equation when we got that the value of omega is equal to plus or minus 2.8. That means that the crossing point with respect to the crossing point of the root locus with respect to the imaginary axis is the crossing point of the root locus. We got corresponding to omega is equal to plus or minus 2.8, that is plus or minus j 2.8. The crossing point of root locus with respect to the imaginary axis, or the crossing point with the imaginary axis, is plus or minus j 2.8, and the value of k corresponding to that crossing point is 48. So, here we got the value of k corresponding to the crossing point. Now, our root locus plot is complete. The root locus have 3 branches. One branch starts at the pole at s is equal to minus 4, and it travels to the negative infinity, and at end ends or meets at the 0 at infinity there. The other 2 root locus branches that are starting from minus 2 and 0, that meets at the breakaway point at minus 0.845 and moves asymptotically along the asymptotes, okay, in this direction, and it again ends at 0. And the meeting point with respect to the meeting point of the root locus with imaginary axis is plus or minus j 2.8. Now, we can say that what is root locus? Root locus is the locus of roots of the characteristic equation of the system. Okay, locus of roots of the characteristic equation of the system. So, this is the locus of roots of characteristic equation of the system. Now, we can see that the locus of roots move to the right hand side. So, what will happen when the locus moves to right hand side? When there are any roots in the right hand side or RHS, the system will go to instability, or system will be unstable. So, here up to the value of k equal to 48, or when k is less than 48, because I have already told you we are plotting the root locus with respect to the value of k parameters varying from 0 to infinity. Up to the value k less than 48, our root locus will be in the LHS, and after that, or when k is 48, when the open loop gain k is equal to 48, it meets the j omega axis and it goes to RHS. So, when the value of k less than 48, we can say that the system is stable, and the limit value of k is 48. After that value, or when you increase the gain beyond 48, the system will have poles at RHS and the system will get to unstable. System will be unstable after that. Now, if in the question sometimes they may ask that if the damping ratio of the closed loop system is, that is theta of the closed loop system is 0.5, find the gain. They may ask the question like that, find the value of k, or find the value of k when the damping ratio of the closed loop system is 0.5. when this type of question is given, the first step is we have to find the dominant poles. So when this type of question is given, we have to find the dominant poles SD, that we can find by using the value of damping ratio. So how can we find that value? So for that, we have theta is equal to 0.5. We know that cos of theta is theta. We have the equation from second module, transient stability specification. Cos theta equal to theta, and theta is cos inverse of theta, that will be equal to 60 degree here. So using this, you can find the dominant pole of the system. Dominant pole location is important because it gives about the idea of in what direction the root locus is progressing. So in order to find in what direction the root locus is progressing, we can find the dominant poles. So the dominant pole can be found out by, we have the value of theta equal to 60. So from the origin, that is from this point, mark the angle 60. Okay. From this point, the angle between the negative real axis and the origin, you take the value as 60. So here take this value as 60 and mark a straight line corresponding to that. So let this point be P, and starting from origin, this angle is 60. Okay. So corresponding to this angle, mark the angle from origin and extend that line. Now this line meets the root locus here. Okay. This line meets the root locus here. This line meets the root locus here at this point. You can see that at this point this meets the root locus, and this is the dominant pole SD. So our dominant pole is, mark the angle theta corresponding to the negative real axis and extend that line, and it meets to root locus, that is our dominant pole. Now in order to find the open loop gain with respect to this dominant pole, what we have to do is mark straight line from this point, that is from the dominant pole, mark straight lines to all open loop poles and open loop zeros. So here in this question we have only have open loop poles. So mark straight lines from this point. So let this first mark all the straight lines corresponding to each poles. Sorry. So this is second straight line and this is third one. Here there are no open loop poles. So let us mark these values as corresponding to this. Let us mark it as this length as L1. Corresponding to this point, let us mark the length as L2, and corresponding to this point, let us mark the length as L3. Okay. Now the value of K corresponding to the dominant pole, the value of K corresponding to the dominant pole is product of length of vectors from all poles to the point S is equal to SD. That you have to find from all open loop poles to dominant pole, you have to find the length. So we already have L1, L2 and L3. So K is equal to product of vector length from all poles to the point. So that means L1 into L2 into L3 divided by product of length of vectors from all zeros to the dominant pole. So, all zeros, here we can say that there are no open loop zeros. Since there are no open loop zeros, we can find the denominator, we can write the denominator as 1 only. If there is any open loop 0 present here, you have to take the length from that 0 to the dominant pole. That we have to write here. So, here corresponding to this problem, there are no open loop zeros. We can write instead of product of length of vectors from all zeros, we can write a 1 here. So, the value of k corresponding to when theta is 0.5, we can find using this equation. We can measure the values using the scale L1, L2 and L3, measure all those values. So, you will get the value of k as approximately you will get the value of k as 8. So, this is the open loop gain corresponding to the damping ratio theta equal to 0.5. Thank you.